What?
I don't know yet.
Ben, we've been taken hostage.
You said you were
I did, but just let me. Much of that was the threat of making sure you guys actually did it. Your directions are going to be to find a quadratic equation having these roots. So we're going to go backwards, okay? I'm going to actually give you a graph, give you two roots, one here at -5 and one here at 3. This is actually the ordered pair -5, 0, and 3, 0. Will, can you get the door, please, when you get a chance? And I'm going to ask you guys to find a quadratic equation having these roots. The first thing I'm going to ask, I want you to know is, I'm just asking for a quadratic equation. So the form of this equation, there are three possible forms that this could look like. One of them is this, y equals ax squared plus bx plus c. Do you remember what that form was called?
quadratic form.
Quadratic form. I'm going to give everything a second name because that could be, we like two names. This is quadratic or expanded form. The expanded just means everything is multiplied out, like terms are added, and you just have a series of terms here. What's the second form I could do?
Graph.
Y equals a times x minus h squared plus k. This is graphing. When in pre-calculus, you guys will actually refer to this as a transformed function, only because it takes a basic x squared and it shows you how it moves left, right, up, or down, as well as what its stretch value is, whether it goes up or down. So you'll kind of be able to, well, we will call it graphing form, and we'll refer to it as graphing form. The advantage of graphing form is that this tells you whether it opens up or opens down. The a value did that. It tells you where the axis of symmetry is. It tells you where the vertex is. This is the form you get when you complete the square. These are the two forms we have done so far. There is a third that we're going to talk about right now. This one's the easier one, and it comes from a factored form. So this is going to be y is equal to an a value times x minus r1 times x minus r2. What do you think r1 and r2 represent? The what? Sydney, I think I heard you say it.
I said roots.
You said what?
Roots.
Yeah, roots. They refer to the roots. Sorry, man. You got to be loud and proud. Given that the question asks you to find a quadratic equation with this having these as roots, this is factored. And these will show you what the roots are, or kind of be a way to go in and to input the roots and get an equation. So if these are the roots, then let's make this equation, this quadratic equation, as simple as possible. Y equals, let's take this with a root of -5. Actually, from this particular equation, I can say the roots are -5 and -3. I don't want to write it as an ordered pair. I just want to be careful. -5 and 3. So one possible one is to say x plus 5 and x minus 3.
What's A
A,
then?
the directions didn't tell me anything about A. So what I'm going to do is I'm actually going to stick in an A value here. I don't really care what A is. A could actually be anything because there are an infinite number of quadratic equations having those as the roots. I'm going to show you that here in just a second. Where are you, Desmos? Flip this over. I just want to show you for a second that you can have an infinite number of quadratic equations that have the same roots with different A values. How do you think that's going to change how it looks?
Is it just that?
A x minus 3 and x plus 5, and I'm going to create a slider on A. I'm going to make this more of a view that you guys can see by putting it in projector mode. And I'm going to actually graph 0, 3, or 3, 0, so I can have ordered pairs there, 3, 0, and -5, 0. So you can kind of see the points there. As I slide A left and right, do you guys see the infinite number that happened? what distinctive point is definitely changing? The vertex. Now, if you knew what the vertex was, then you could actually find one distinct, unique one. But without knowing where the vertex is, without knowing where A is, you have an infinite number of them. The directions are going to actually ask you to find a single quadratic equation. So what I would say is the simplest is if A is equal to 1, and we're just going to say y equals x plus 5, x minus 3. It's the simplest if A is equal to 1 on this one, but you can do any other one.
You don't want to like boil up?
Not right now. You may have directions that ask you to do that.
Do we have to write that if A equals 1?
If A equals 1. You know what, Andrew, let's go ahead and FOIL this for this one, just for kicks. X squared plus 2x minus 15. What form is that? Quadratic. So let's say that I have R1 and R2 as the roots. I basically want to try to figure out a quicker way to get the expanded form. Well, knowing what the form is going to look like, y is equal to A times x minus R1 times x minus R2. What I want you guys to do is FOIL that. X squared minus what? Come on, just FOIL. XR2 minus
XR1
plus R1, R2, or R2, R1. Okay. Let's write this with this a little bit more factored out. Just that little part. X2, or x squared, minus, what's the coefficient of the x here? If I were to factor the x out and pull the x off to the right, what would the coefficient be? What am I actually doing? Negative what? What am I doing with the two r values?
R squared plus R1.
Yeah, R2 plus R1. We'll put it as R1 plus R2. This is just factoring it out and saying, what are we actually doing? You guys know when you add two negative numbers, you add them and you make it negative, right? That's what you're actually doing with those. And this is kind of the key thing I want you to really know for today. Because this part right here represents the sum of the roots. And this part right here represents the product of the roots. So I want you to watch how this can make the problems go a little bit quicker. I don't actually have to write them out so completely. I could do this faster. And that's the goal of today. I want you to be able to do it faster. So here's what I'm going to do to make it go faster. You see two roots there, right?
Yes.
I'm going to add them. R1 plus R2. What do you get?
Negative 2.
You get negative 2.
First I win.
Okay. Underneath that, what's the other thing I need? That was R1 plus R2. What's the other thing you need?
The product of them.
R1 times R2. That,
You get 5/4.
you get negative 5/4. So I have R1 plus R2, and I have R1 times R2. And what I need you guys to do is now say y is equal to A, x squared minus R1 plus R2 plus R1 times R2. You're going to substitute. You're going to take this negative 2 and substitute it in for R1 plus R2. Y equals A, x squared minus, what is R1 plus R2? So minus negative 2 gives me plus 2 times, forgot the x. And then plus R1, R2 is plus negative 5/4, so minus 5/4. Your directions will ask you to pick an A value. pick A to give integer coefficients. So you get to choose whichever A value you want. I would choose 4 as well. Make it the simplest possible A. Don't do that. So I'm going to go y is equal to 4 times x squared plus 2x minus 5/4, and we're going to simplify that to y equals 4x squared plus 8x minus 5. Yes, no?
You choose 4 because that gets rid of the fraction.
I do. You could choose any integer value you want that would get rid of the fractions. You could choose a -4. You could choose a -44. Let's just go the simplest one, just to keep it all the cleanest. Okay, I want to do a couple more of these. Number 4, I'm going to give you 1 plus root 5 and 1 minus root 5. This isn't as bad as it looks. Also, you need something? Or? For 3, are we not going to factor it? I'm not going to. I don't need to. I know that would actually factor into 4, and then x minus a half, and then x minus or plus 5/4. My goal is actually to kind of jump right ahead to the quadratic form as quickly as I can. Okay, I've got these 2 roots. What's the next thing that I want to do with the 2 of them?
Add them.
We want to add and multiply. So find the sum is the first thing. R1 plus R2 equals
2 are, or just 2.
just 2. R1 times R2 is 1 plus root 5 times 1 minus root 5, which is 1 minus 5, or -4. Now we skip right ahead to y equals a x squared minus, I'm going to do minus the sum plus the product, which is actually minus 4. X squared minus the sum of the roots times x plus the product. Sometimes I write it like this, and if this helps you, great. If this doesn't, then don't worry about it. But I write it like this to kind of tell me in my brain that that's how I'm actually doing it. X squared minus the sum of the roots times x plus the product.
So then how would you come up with an A value?
You get to pick whichever one you want.
Is it? Wait.
I'm going to pick one.
Oh, just 1?
Yeah.
You have to complete the square?
No, not right now. And not really, I mean,
Not for the next day and a half.
if I wanted you to, like the goal right now is just to get an equation. It's not to graph it.
But eventually we'll have to graph this.
Well, you see, you're graphing. I'm actually asking you to pick an A value, so there's no way that everyone would have the same thing. I mean, logically, you guys could all pick one, and that's fine, but that's not the goal right now. I know you know how to, like, graphing them is the other lesson.
Wait, how did you get -4 for the product? Because
1 minus 5.
how did you get there?
When I multiply the 2 of them, I FOIL them, first out or inner last. Here, Andrew, I get
I got it.
1 minus root 5 plus root 5 minus 5, or -4. Okay. So let's go to, well, I want to do one more example with radicals, then we're going to skip ahead to one with without them. 2 plus or minus root 5 over 3. Yes, no?
Will you give us the roots?
Well, you'll find out. This is one of those skip ahead questions I'm asking you to hold off on. Okay, 2 plus or minus root 5 over 3. When I say plus or minus, what am I really meaning here?
There's 2 roots, and one of them is plus and one of them is minus.
So if it helps you to write it like this, then do that. We want to do the sum of the 2 of them. They already have a common denominator. So when I add them, what do I get?
You get 4
4
over 3.
over 3. When I multiply them,
You get -3 over 9, which is
-1. So I get 4 minus 5 over 9.
Oh wait, I read the 9.
Yep, careful, 3 times 3. And we get -1/9.
Wait, no, I just forgot to multiply the 2 by 2.
Wait, there's only one.
There's only one,
No, but it's got a plus or minus, so one of them. So
which
you
means
make
two-
that into two roots.
two different ones. So now I get y is equal to a x squared minus the sum. So minus 4/3 x plus the product minus 1/9. Let's pick a equals 9 because that's the easiest. So I'm just going to pick an a value where a is 9. You can pick whatever a value you want, but your directions will ask you for integer coefficients. So you need to pick one that clears fractions. And let's just pick the simplest. 9x squared minus 12x minus 1. Okay, 2 more, and then we're going to do a different problem type, then we'll go over homework. So the next 2 have roots that are complex. So I just had a conversation with one of you about complex roots and what they mean. On a graph, on an equation like this means that the parabola will not cross the x-axis. Isn't that possible?
I don't know. I had you say so.
Yeah. Can you draw me a parabola that doesn't cross the x-axis ever? I can draw 2. I can draw one like that. Or I could draw one like this. Well, careful, a parabola that's sideways is not a function. It won't be a y equals. It will be an x equals, and save that for pre-calc because we will do lots and lots of those.
Because you'll
Yeah.
never know when you're cornered by a y, by a
No.
I.
No. No, I'm telling you, this is a graph of x, y. So imaginary numbers in x won't be graphed. This is not the same as graphing. We can't because that real and I would all have to be in x. What you can do, and this is much, much, much later, is you can do a 3-dimensional plane where one plane represents the x's and the other one represents the y's in 3 dimensionals and it's crossing of the planes. If you graph these in 3 dimensions in complex numbers, you can actually visualize these roots, but that is much later. So right now, I just need you to see that there are 2 roots, 3 plus I, or negative 3 plus I, and negative 3 minus I. Okay, look at me. Anytime you have complex numbers as roots, they will always be conjugates. Anytime you have complex numbers for roots, they will always be conjugates for now. So the sum, R1 plus R2, should knock out the I. What do you get?
Negative 3 plus 3, or minus 3 is negative 6.
Negative 6. R1 times R2. Now let's multiply. This should also knock out the i's.
9.
So
It would be
10.
9 minus I squared is 10. We have negative 6 and 10, and we're going to make the equation y is equal to x, or ax squared, so I should put the a in front, minus a negative 6 times x plus 10. You know, it's a really funny example is then to ask a part B question and say, now do the quadratic formula on this and tell me what roots you get.
Oh, it's 3 plus or minus
Yeah,
I.
that's the whole point. You're going backwards. You guys see you're going backwards from the roots to the equation. You were going from the equation to the roots. Now you're going from the roots to the equation. How do you think I do this when I want to give specific answers and then build the problem for you? This is honestly how we do it. Mrs. Manton and I will make an answer key first, and then we'll make this, do the sum product and make the formula worksheet out for the solvings. So what a value we're going to pick, by the way?
1.
Yeah, just pick a equals 1. I'm going to go y is equal to x squared plus 6x plus 10, and we're done. You guys, if you want to learn, you could actually graph these on your graphing calculator and see, oh, it doesn't cross. But the x-axis. Because that's what's going to happen if I have complex roots. We're going to do one more with complex roots, and then we're going to be done with this set. Sorry, that's number 7. We're going to go 3 plus or minus I root 2 over 2. So I'm going to write them off to the right side. 3 halves plus root 2 over 2. And actually, you know what? We'll keep them all together because it's a little bit easier to add them. 3 plus root 2 over 2, comma, 3 minus root 2 over 2. I. And I want to add them. R1 plus R2.
That would be
6 over 2, 3.
6 over 2, which is 3. And then I want to multiply them, R1, R2. Just do it slowly. First You get 9 minus 2i squared over 4, 11 fourths. So then I get y is equal to a, x squared minus the sum of the roots times x, plus the product. I get to pick whatever a value I want.
4.
And I get y is equal to 4x squared minus 12x plus 11. Okay. 2 more questions to go, and then we're done with it. We're going to change the question type on you. And I'm going to give you guys an option on some of these. Find a quadratic function in quadratic form for something where the max value is 4 and it has x-intercepts of -1 or -5 and -1. Okay. How can I do this?
Well, you know that it's a parabola that faces down. And you know that the y value...
I do. Andrew, how do I know it's a parabola facing down?
Because the max value is 4, so...
Yeah, or it just has a max value in general, right? The fact that it says max value means it's going down. Where's it crossing here?
-5.
-5, -1. I am willing to bet, and I'm going to give you guys just a second to kind of figure this out. I'm willing to bet that all of you, knowing this, and I'm going to delete this and just kind of fix this and make this a little bit larger. I'm willing to bet that every single one of you can figure out what that ordered pair is.
-3.
Hang on.
-3.
-3, and what's the y value?
3.
4.
4.
Shut up.
Hang on.
Wait, how would we figure it out?
Well, it says the max value is 4, so that means it
I didn't even see that. I didn't even see that. I don't even know what
says the max value is 4.
And it's right in the
With
middle
those
between
words.
Shh, okay, guys, one at a time. One at a time. I want someone to give me a verbal explanation of where this ordered pair came from. Okay, go, Andrew.
The max value is 4, so you know that's going to be your y value, the vertex. And because it's a line of symmetry, you know it's going to be right in the middle, -5 and -.
Exactly. So you guys actually know from the information given in the problem that HK is -3, 4, which means you now have 2 different ways you can do this problem. Yes, sorry, Glenn. If it's what? We don't know what the A value is, though. That's the only problem. I know what you're saying there, but that's only if A is equal to 1. Then we can go 1, 1, 2, 4, 3, 9, and so forth. What I do know is that I have ordered pairs of 3, 4. I have 2 more ordered pairs on this graph. What are they?
The x-intercepts.
-5, comma, what?
0.
And -1, 0. So option 1 is to do sum product, like we just did. R1 plus R2 is what?
I'd be doing the other thing.
Oh, come on. What's R1 plus R2?
Which ones are?
The roots, the x-intercepts, the zeros. Remember,
-6.
what's R1 times R2?
5.
5.
So I know that this is y is equal to a x squared minus the sum times x plus the product. The only difference is I can't just pick any arbitrary a value now. I have to solve for what the a value for this particular one actually is. If only you had one other ordered pair on this graph that were not the roots to plug in and figure out what a value is. You do. We have the vertex. So I'm going to plug in 4 is equal to a. -3 squared is 9 minus 18 plus 5.
Do we have to do a substitution step here?
I am. I'm substituting 3, 4. Oh, no, you don't have to. I'm fine. So yes, you get a is equal to -1. This does mean it has Clay's quadratic pattern here. It's just an a value of 1. But My final is going to look like this. Y equals negative x squared minus 6x minus 5. Option 2. Oh, this is good for you guys to know, because we have the vertex. So maybe I could start with this form and plug the vertex in. Vertex is, looking back up, negative 3, 4. So y is equal to a, x minus a negative 3 squared plus 4. I just plugged the vertex in. I almost have an equation. I'm missing the a value, and I need to plug in any other point other than the vertex. One of the roots. You got two options. So I'll plug in negative 1, 0, and go 0 is equal to a, 2 squared plus 4, and a is negative 1, which, yes, we knew a was a negative 1. So then I get y is equal to negative x plus 3 squared plus 4, which if you wanted to go to quadratic form, you just have to multiply the whole thing out, and you can. Or let's say you wanted to go graphing form, maybe that one's easier to start with because you know you're going to end up in graphing form. The theme of this is that you're using a method that uses one thing and then you have to plug the other one in. Okay, final one. I'm going to leave this to you guys.
And after all that, you can finally solve a problem that existed only in your head the entire time.
The minimum value is negative 25. The x-intercepts are negative 2 and 3.
What's the point of that?
Like,
Hang on. Let's use the R1 plus R2 method here. So I'm going to go R1 plus R2. Guys, come on. We want to leave time for going over homework. R1 plus R2 is 1. R1 times R2 is, which means that I know that my equation could be y is equal to a, x squared minus 1x minus 6.
what? Sorry? What? You know, never mind. I don't care.
It's 1 times x times.
Yeah, there's a 1 here, Andrew. This one.
The R1 plus R2 goes there.
Oh, you're right.
I need to plug in. I need to plug in anything, and I can plug in hk. I know that it's h comma negative 25. How do I figure out what h is? H is halfway between what two values? What I can say is h is the average of negative 2 and 3. What is the average of negative 2 and 3? 1/2. Negative 2 plus 3 over 2, 1/2.
Idiot, you said 1.5.
So I know that hk is 1/2 negative 25. Plug that in. Negative 25 is equal to a. 1/2 squared is 1/4 minus 1/2 minus 6. Or negative 25 is equal to a. You can clear by multiplying both sides by a 4. You know what? I'm going to do that. Let's multiply the left and the right side by a 4. I get negative 100 is equal to a times 1 minus 2 minus 12.
Would you multiply the a or not?
No.
Wait, would it be minus 12 or would it be minus 24?
Oh, it'd be minus 24. Thank you. So we multiply by 4. So 1 minus 2 minus 24. We get a times negative 25. And I get a is equal to 4.
Sure.
So then let's go back down here. Y is equal to 4x squared minus 4x minus 24.